Okay, in this video we're going to talk about the existence of solutions to AX equals B. So let's just recall that if you have a matrix A, so let's say that A is an n by n matrix, and B is a vector in Rm, we can try to solve the equation Ax equals B, and A is an n by n matrix, and X is going to be a vector in Rn, right? X is going to be a vector in Rn. And we're looking for a matrix in Rn, all the matrices in Rn, such that A times X equals B. And we know that if, so you row reduce this augmented matrix and if you get something like, so if you get a row of zeros and then a zero, okay, that doesn't mean anything. But if there is a row of zeros and then something that's, not zero, then this means that your system is inconsistent. So Ax equals B has no solution, right? If you get something where, so otherwise it does have a solution. And so in that case, you're going to get, so if you get something where you have a pivot in every row, so if you have something that's like 0 and then 0, so maybe you have a bunch of rows of zeros, right? All 0 rows. And then you don't have this, right? So it's, I should maybe indicate that it's this part that's telling you that you have no solution. Right? If you get that, then there's no solution. Otherwise, it does have a solution. And you're going to get something like this. You're going to get a bunch of 0 rows, and then there's going to be a pivot, like pivot entries, and then zeros, and echelon form might have a pivot here, and then say like a pivot here, and then maybe a 0, and then something. Right, okay, let's make that clearer. That here's a separate row with the pivot, so these are your pivots, these stars, right? A non-zero number, the first non-zero number of a row, you get something like this, and then something, something here, then the system is consistent. So you have these zeros here, then the system is consistent, so Ax equals B does have a solution. And if you get something like, so do you have one solution or infinitely many solutions? Well, if you get something where you have, so let's just throw in some 0 rows. If you have a pivot, so you're looking for free columns. If there are no free columns, no free variables, then Ax equals B has one solution. If the system is consistent, and no free variables, then Ax equals B has one solution. So it's going to look something like this. Okay, and then you have stuff. It's going to look something like that. Then Ax equals B has one solution. If you get something like this, where just throw in some rows of zeros, and then you get something like this, you know, and then there's all these entries here, right? So these are not going to be pivots, so these are just random numbers. Something like this, and just some random numbers here, right? Then the system is consistent, and there is a free column. Then AX equals B has infinitely many solutions. Right, so these are you have pivots here, here, and here, say. Okay? Yeah. So let's look at an example. Let's say that you have A equals 1, 2, 3, 4, and B equals 5, 6. Is there a solution? Does AX equals B have a solution? Well, let's set up the augmented matrix and row reduce. So when you do that, you're going to get a row 2 goes to row 2 minus 3 times row 1, so you're going to get 0 here, and negative 2, and negative 4, right? No, negative 9. Because the first row, when you multiply by 3, is going to be 3, 6, 15. Okay, so you're going to get this. And now we see that this does have a solution, yes, because I have a pivot. I look at this is an echelon, this augmented matrix is an echelon form, right? This part is an echelon form. And when I look at the first non-zero number, okay, those are my pivots, I don't have a row of zeros and then a non-zero number in the coefficient part, in the constant part, so to speak, right? I don't have anything like this. So this does have a solution, and there's exactly one solution. Okay. Now the question is, let's think about this. What if B was a different vector? What if B were a different vector in R2? Then would AX equal B have a solution? Well, what do you think? If you change these numbers, 5 and 6, to any other number, could it be that, you know, maybe you can come up with two numbers, like maybe you can come up with a different vector, and then when you do it, there's going to be no solution. Do you think that's possible, or do you think that every single B, your AX equals B is going to have a solution? Well, why don't you pause and think about this for a few seconds, and then like unpause the video, and then we'll go over the answer. Okay, let's go over the answer. Well, the answer is yes. AX equals B has a solution no matter what B is. I mean, this is if B is in R2, right? No matter what B in R2 you use. How come? Because if you think about it, okay, let's just have a B1 and a B2, just like a random B, right? If you do the row reduction, you're actually going to get the same thing. Like, if you pay attention to the coefficient part, nothing about it is going to be different than in this example. So you do row 2 minus 3 row 1. This is going to be 0, and then negative 2, and then B2 minus 3 B1, right? So look at these coefficient matrices. They're the same as what I had in the previous example. Because you're doing the same steps. So now you can see that it doesn't matter what B1 and B2 are, because you're going to get this. You're not going to get the situation where you have a row of zeros in the coefficient part in this green matrix, right? You don't have a row of zeros, and so AX equals B is going to have a solution no matter what your B vector, no matter what your B1 and B2 are. Of course, the solution is going to be different, right, depending on what your B1 and B2 are, but it doesn't matter when it comes to the question of is there a solution. The answer is going to be yes. Okay. So let's write that down. So the reduced, or the row echelon form of A, the thing is it has no zero rows. The row echelon form of A, this matrix, right? This matrix. This has no zero rows. And so, right, what's the general principle? The general principle is, in general, if you row reduce A and you get a matrix that has no zero rows, okay, and we're only talking about the coefficient part, this part. If that has no zero rows, then AX equals B has a solution for every B in Rm. Okay? If the echelon form does have a zero row, then it's going to depend on what your B is. So let's look at it. Let's look at this example. Let's say that you have A equals 2, 3, 6, 9. So let's say that's your A. And your B is, let's just see what happens when you have a random B. So just a generic B, you don't know what the components are, it's just B1 and B2. Okay, then what happens? Well, when you do this, you're going to do row 2 minus 3 row 1 again, and then you're going to get this, 0, 0, B2 minus 3, B1, correct? Yeah. So when does this have a solution? So AX equals B has a solution. See, now it depends on what B is. It has a solution if this thing is 0. Because if this is 0, then you're just going to get a, you're going to have a pivot, so your 2 is your pivot, and you're going to be able to solve for B1, B2, right? In fact, you're going to get infinitely many solutions. So AX equals B has a solution if B2 minus 3B1 equals 0. i.e. B2 is 3B1, right? But if, so AX equals B does not have a solution if B2 minus 3B1 is not 0, because then you're going to get, 0, 0. The second equation is going to read 0 equals something that's not 0. That has no solution. Okay, so for this A, right, whether AX equals B has a solution is going to depend on your B. But in this previous example, okay, for this A, it didn't matter what your B is. AX equals B does have a solution no matter what your B was. So that's the difference between that example and this example. And we can actually graph what this looks like. B2 equals 3B1. I mean, okay, that's gonna be like, here's the B1, you know, axis, or let's just use that. Let's just call it x and y. Okay, so this would be like y equals 3x. Right? If your B1, B2 is on this line, right? For these B1, B2s, ax equals b has a solution. Okay, so for these vectors, for this vector b1, b2, this is the line, this is y equals 3x, ax equals b has a solution. But for any other vector, so let's say this vector is b1, b2, for this vector, ax equals b has no solution. Okay. And you can see what's going on if you look at these column vectors. It's 2, 6, and 3, 9. 2, 6, and 3, 9 are lying on this line, right? So any vector, remember, any vector for which ax equals b has a solution is going to be a linear combination of the columns. So that kind of makes sense, right? You have to be a linear combination of these column vectors. And when you look at the linear combinations of these column vectors, you get the vectors on this line. And in fact, how many solutions, suppose that ax equals b does have a solution in this example, how many solutions are there going to be? Well, if there is a solution, okay, what's going to happen with this matrix? This augmented matrix, the augmented matrix looks like, when you row reduce, to echelon form, it's going to be 2, 3, B1, 0, 0, 0. So then this equation is going to be 2x plus 3y equals b1, right? And there's going to be infinitely many solutions to this. This has infinitely many solutions. So in this example, for this matrix, there either is no solution or there's infinitely many solutions. And that's because if there is a solution, then this second column, because this second column is a free column, right, there'll be infinitely many solutions. Okay, so let's review what we did. So the point was, first of all, we reviewed when ax equals b has a solution, and then we saw that because of the way it works, if the echelon form of A has no 0 rows, then ax equals b has at least one solution no matter what b is. And in contrast, there's this matrix where the echelon form does have a row of zeros, the echelon form of A does have a row of zeros, and then it's going to depend on, you know, your individual B. So if B, there are going to be some linear combinations of the columns of A that will give you B, but then there are going to be some B's that are not linear combinations of the columns of A, and then those B's will not. AX equals B won't have a solution. Okay, thanks.